So thank you for the last presentation, and thanks also to the previous presenters. We enter now the question and answer session, where you have the opportunity to raise your question directly from the room or using the Slido tool. So we'll open the Slido system. Okay, so the question and answer session covers the four presentations we have on quite different subjects. Is there any question from the room? Yes, I see one on the right. If we can give a microphone. Please use the mic because it's recorded.
Asking the Sikorsky rep, looking at the Paris incident with the 320 where they misset the altimeter, will the Sikorsky products do the same as the 320 did? Do you know about the incident?
Yes, I'm familiar with the incident, yes.
Have you got the problem? Because I think Leonardo and Airbus may have.
Yes, that problem is not on in the models rad altimeters that we have, but we are looking into that mode to potentially make sure that we don't get into that mitigation issue, but I am familiar with that, yes.
Saying you do have the problem.
We don't have the problem. It's just that we are looking to make sure that other platforms don't have something similar to that, because there could be other escapes there related to that were not the direct cause of the of that particular incident. We're talking about the Turkish one, right? Was it a Turkish Airlines? I think.
No, it was no, it's the Paris one with a.
No, what was the airline?
Registered Norwegian crew.
It was Norwegian crew. Yes, that was.
They set the
right.
The bar out 10.
Right, they made a mistake with that. Right,
yeah.
Right.
Thanks.
You're welcome.
Okay, can we put a Slido question on the screen? Yes, we have one question for you from Alexander Smerles, if you want to take it directly.
How many flights for? Good question. So let me explain what we did in Utah. And this has to do with the statement that I made earlier for the testing that we did with the UH-60. And that was a Honeywell unit in that aircraft. It's public knowledge, so it's nothing I'm saying that's divulging anything that's not already on the web. We actually did multiple tests. We did what I call multiple altitudes. In other words, we flew a fixed radius distance starting at approximately 1 mile with 360-degree hover turns at 3 different altitudes, doing it at 50 feet, at 200 feet, and at 500 feet. And then we actually progressively moved the aircraft closer as we did 360s until we got to the 200-foot distance from the antenna. We also set up a point-in-space approach. For those of you, I don't know if you're familiar with PINS approaches. We set basically it's almost like a tactical approach if you're familiar with military approaches. And we've set the PINS approach to be within 300 feet of the Verizon emitter tower, so that the array, each array on a 5G tower is about 120 degrees focal length. We only had one on that one, so I made sure that we were on the center beam of that. So we did a PINS approach, also no issues. And then we did station overpasses, about 5 or 6 of them from multiple directions. We did low speed, about 30 knots, we did 70 knots, and we did 110 knots. So we did quite a few passes, and yeah, it was very. I was trying to break it basically. That's the way to look at it. I was trying to intentionally force the RADAL to either RADX me on an erroneous return, which is what I was expecting, or give me. I was less concerned about getting a erroneous indication. But yeah, we did sufficient testing that clearly showed that there were no effects. Again, the thing to remember with the Verizon test in Utah is the array was only capable of going to 58 dBm, right, per megahertz. And every 3 dBm, you're doubling your power. So there's a big distinction there. I hope that answers the question.
Thank you. I see another question in the room. Please go ahead.
Bernd speaking. Bernd speaking. The question is to Giorgio with regards to the data approach. So very interesting for myself. My question is, because you mentioned that there will be a kind of automatism if you have a sensor failure, for example. You mentioned that there is verification of data. How could you detect that sensor failure, if it's more or less submitting the wrong kind of data set, if this is not going through the whole chain so that your excerpts and analysis results are spoiled? Would be just interesting.
Okay, can you please a little bit clarify? I mean, we are going to get a complete set of data. Of course, we want to start from the basics. So basically, the amount of data is huge. So there is, when we talk about prevention, the approach is to analyze all the data, to use a machine learning algorithm to go through the data and to learn from what we see. So basically, of course, validation of the data from one point of view means we need to ensure that what we receive is something that we do know and we expect it to be valid, okay? Then if it's invalid by definition, so a sensor going out of range, for example, it will be picked up immediately because it's out of scale or it's at the band of a scale when it's not supposed to be there. So that's picked up immediately. If it's still in the range, then the idea is to learn about all the other parameters and validate the parameters in terms of, yes, this is expected or this is not expected. Let me give you an example. If you, one of the projects that we do have is, or one of the targets is to recognize how the aircraft is flying, which means if it's on a cruise, if it's going at a certain speed, if it's performing turn, how the turn is performed, all this kind of stuff. So by definition, we can have all the parameters and make a comparison between what is supposed to be a sensor data during that phase of flight versus what we get. And if there is a discrepancy, it's something that we also will be able to pick up. So I don't know if it's going to answer to your question. It's just basically a huge analysis that we want to perform on under this aspect.
Actually, it's applied quite well, I would say, but there is probably a different question or another question.
Okay.
If you take the sampling rate, so you just mentioned that you are as well observing occurrences.
Yep.
So if the sampling rate is, let's say, too broad, so that you cannot detect what happened in that occurrence, what would you do with this?
Yeah, of course, that's another point. Basically, what we do have on our aircraft is to have a sampling rate which is, I don't know how to say better in English, maybe it's not the right wording, but well above the minimum specification. So what we know is that, for example, of course, there is still the possibility that there is an event, milliseconds, hundreds of seconds, which may not picked up, okay, because of the sampling rate or because of the technology. So this is something that we are aware of, but we need to start. So, of course, there is a performance, but in any case, this is the performance that we do have today, and this is the performance that we are going to increase, but it's something that cannot prevent us from moving onwards under this point of view, knowing that there is possibly, yes, you're right, a limitation in terms of sampling rate of one parameter that we want to check, of course. But we do not expect to have events which may happen in milliseconds or hundreds of seconds. Okay, of course it may happen, but the probability of them to be there for such a short time frame, it's not so high.
Okay, I can invite you to take the next two questions on Slido because they are on the same subject. And if you can also read the questions.
Yes, is the application using FDM, FDR data used only for CAW purpose, or does it also support CVP verification? And the question, okay. We want to go to the maximum extent possible. So basically, one of the key elements is really to go, and that's a technical challenge that we need to face. So we want to use it to the maximum extent possible and to go to the max requirement that we can cover with all the data and with all the algorithm that we have put in place. And then there is another question. What are the conservatism addressed by the safety digital tool? Okay, it's for you.
Okay. So maybe the failure condition criticality is one point, because our FHA typically address the most critical condition. And when we analyze the operability of the helicopter that experience a failure, sometimes they have, for example, they may have a different operation. They may perform different operations with respect to the most critical condition addressed in the hazard assessment. But also the fact that we use latency, which are related to the entire life utilization. And when we analyze to the issue to provide a tailored, to try to provide a tailored answer for a temporary return to flight activity, we may take credit on the fact that the helicopter have a certain amount of flight hour with respect to the latency that we used in the certification document, for example.
Thank you. I see a question there and a question there in the middle.
Hi. My name is Clementino, which is Clermont in France. I work in Brazilian Civil Aviation Authority in Aviation Safety Department. As I could see from Sikorsky's presentation, the 5G is a very short future reality, and there's nothing, it seems to me, as per your presentation, there is nothing that FAA, EASA, or Brazilian authority can do about it. So my question is, what the working group you are on have considered to solve this problem using old technologies like Doppler system, which is very used for SAR missions, and the possible novel short future technologies that could be applied to substitute the old technology of readout, which is, it doesn't seem to me that maybe it's not possible to keep using it for short future. So, and when we see, as per your presentation, for example, Sikorsky S-92 helicopter, you have 309 helicopters flying worldwide. More than 70% of them work for offshore doing rig approach. So it's a problem. with the 5G technology. Yeah.
Yes.
So again, my question is: have you considered the old technologies like Doppler, or and which are the brand new, probable new technologies, novel technologies about to solve the problem? And the question also for our friend from Norwegian. I know you have presented that you work with small helicopters, but have you considered new technologies to solve this short future problem with the 5G?
We can get started with the 5G part.
Sure. Yeah, excellent questions, by the way. Thank you, and it's a very good point you raised. Let me start something with you said in the beginning, because it's important to distinguish it. I think the FAA has been going this alone for a long time, and they've got a good team going. It's a very international and diverse team with support from a lot of players in the industry. I know Embraer from Europe. We have several people from Embraer supporting us too. Right now, we are trying to raise this awareness with EASA here too, to try and get a more global push towards standardization of a possible solution here, because this affects everybody. There was this thought in the beginning that because the implementation of 5G in Europe was different, or in Asia was different, or Japan was different, for example, that this would not affect everybody, but it has become apparent that it does affect everybody just because of the way air transportation and cargo moves across the planet. With regards to your question, so I think with EASA, we're just beginning to engage EASA and FAA together as a joint team to push back at the cellular providers for that frequency range. So that effort is kind of just beginning now. With regards to your new technology, excellent question. Doppler, out of the question. Doppler is an old technology, lacks a lot of ability to adapt. It's got a lot of issues in terms of size and reliability also. What we are looking, though, however, is LiDAR. I can tell you that. We're looking at multi-phase radar. Multi-phase lasers. We are looking at several other technologies to measure altitude above ground, because AGL is, like I said in the beginning of my presentation, limited to Radalt right now, and it's a problem. So LiDAR right now with some type of fusion with some other sensors is what we're experimenting. At least I can say this from my company. From Lockheed Martin, we're looking into this. I know Honeywell is also kind of looking into that stuff. There may be others, but we are definitely looking towards other technologies. The problem we're having is that we have to develop a system and then certify it. And that solution is going to be at least a 2025, 2026 solution. That's not going to address the immediate problem where we're faced with right now, where the FAA can shut down and affect global air transportation by prohibiting landing and usage of airports that are surrounded by 5G towers. So that's the imminent problem we have. But we are definitely looking at long-range different technologies to substitute it. Unfortunately, there are also long-term developments, and they're not going to come in time to save us from the immediate issues that we have right now. I think the other question was from my colleague.
From the Dutch Aerospace Center. So this issue is definitely on our radar. We don't have any project currently with manned helicopters, but we do have the ability to test unmanned aircraft and see the effects of interference. So yeah, I would for sure invite you, if you want to test it out, to come to our drone center, and we have a dedicated airspace where you can test this kind of thing. So it's definitely on the radar, but not yet looking at it from a manned aviation perspective.
I'm conscious of the time, so I think we can take one or two additional questions for today. Please.
Yes, can you hear me? Yes, that's better. Yeah, Gilles Brugnot, Head of Product Safety of Airbus Helicopter. It's also a question about the 5G. If I make it simple, today, the radar altimeter OEM are working on filter, and we, as OEM, we are working on integrating the modified radar altimeter. But you spoke about something I was not aware of, about July 2023, and I have not understood exactly what's going to happen, and what is the risk that the modification that we are developing right now will be completely useless because of this modification.
Excellent question also. That is really the problem we're having right now. The current filters that have been developed jointly with a lot of the members of the committee that we've been working with, and with, let's say, Thales, Garmin, Honeywell, Collins, to say a few, and with my fellow tech fellows from those companies, those filters are really designed to address the spurious emission and the RF environment that we have today. Today being 2 nautical mile protection zone around major airports, 32 dBm per megahertz transmission within those zones to limit transmissions within the landing zone of those airports, and a 62 dBm per megahertz, or 1.6 kilowatts for those who can't do the number quickly, power transmission, peak power. In July of 2023, and right now we only have 2 operators in the US using 3.7 and 3.58 gigahertz, AT&T and Verizon. In July 2023, but now before that, in December actually we're going to start. First of all, December 1st of this year, power levels will increase from 62 dBm cap to 65, which is going from 1.6 kilohertz to 3.2. So automatically, your power spectral density will increase with spurious emissions. And really, it's not your main lobe of a transmission that's causing the problem. It's the spurious emission that's emitted from those transmission arrays that cause the havoc, because they can't really be controlled really well by the cellular operators. On July of 2023, you will actually open up the spectrum all the way to 3.89. So you will get even closer to the 4.2. And you will have 4 more cellular operators going into that same frequency range of 3.4 to 3.8. So your spurious emission levels will go even higher because now you have more players. And we've also know that even transmitter to transmitter, there's actual cross interference. So the noise level, if you want to call it that, is going to basically go up. So the filters you have today are most likely, and the FAA knows this, they're not going to work after July 2023.
So, last question for today. I see one. Yes, please.
Good afternoon. Jean-Marc Sacaz, a former EASA Rotorcraft. Just a remark, not a question. To avoid any confusion, it should be better when you present your last document there to talk about height. I know you are talking about radio altimeter. Probably the wording is not the best. Talk about the height, please, and not to the altitude. Because at different time you mention altitude, and as soon as we talk radio altimeter, it's better to talk about the height over the ground. Thank you.
Then, that was the last question for this session. Thank you very much for your interesting question, for your participation. Thank you to all the presenters for the presentation of today. So that's now closing this session. We will start again tomorrow at 10 o'clock in the same room for the next part of the EASA Rotorcraft and VTOL Symposium. Thank you very much, and enjoy the evening in Cologne.
Thank you.